Sabaijanलाई namaste. So I think we all are from Nepal. I think so no one is from beyond our country. So so this is our third episode of the Kusod webinar series, especially focused on mathematics education, and so pedagogical and teaching and learning practices around mathematics. So today, actually, we have two, very much important presentations. So the topics and the, context and the contents are very, very useful in the school education system, that is for, kindergarten to 12 education system. So the, the topics are, yoga in mathematics classroom. And so another, burning and the important topic is that Vedic mathematics for mathematics education, mathematics curriculum, and the teaching and learning practices. So here we have two friends. So they are also the graduate of Kathmandu University Department of System Education. So the first one is Anita Joshi ma'am, and similarly we have Prem Raj Joshi sir for the presentation today. So I think we should begin. So Prem sir, are you ready with the presentation?
Yes, sir.
Okay. So Prem Raj Joshi sir will be presenting his ideas here and his understanding, and so whatever he found from his own experiences as well as the research. So he'll be presenting on the topic of Vedic mathematics for mathematics curriculum and mathematics education. So I request Prem Raj Joshi sir to present your slides. Start your presentation. Over to you.
Is my screen is visible, sir?
Yes, sir. Yes.
Hello and namaste to everyone, all the respected teachers and all my friends. Today I am going to give a presentation on the topic of Vedic mathematics in school mathematics. How the Vedic mathematics can be incorporated in the mathematics classroom. This is my topic of presentation. So these are my outlines or a table of contents. First, I will describe briefly about what is Vedic mathematics, and I will discuss about its sutras and subsutras. Then demonstrate how these sutras and subsutras will works. Along with that, I will engage all the participants in the activity. After one sutra, I will motivate you to participate in the activity as well. And finally, I will give some implications or applications of Vedic mathematics in the coming dates or in today's time. So Vedic mathematics from the word itself, it has some meaning. It just means that it is the mathematics which is related to the Vedas, or we can say it has its underlying principle which are based on the Vedas. Although Vedas are considered as the source of all the knowledge in the Hindu philosophy, in this this Vedic mathematics is actually derived, or we can say extracted by the one Indian, Mr. Bharati Krishna Tirthaji, Sri Bharati Krishna Tirthaji. Actually, Vedic mathematics is the mathematical ideas which are extracted from the Vedas, especially Atharva Veda. After a rigorous study of about 8 years, he has formulated some sutras and subsutras which can be used to solve the mathematic problems and to do the mathematic calculations. In this Vedic mathematics book was published in 1965, and this book consists of the sutras and subsutras, which is considered as Vedic mathematics. Actually, although Vedic mathematics implies the mathematics of which are taken from the Vedas, but it is famous due to this book, and we can say this is the kind of the domain. If we search Vedic mathematics simply implies the mathematical these sutras and sub sutras which are published in the book Vedic Mathematics. Okay, so yes, and the another important feature of Vedic mathematics, or the Vedic mathematics, is very well known, or we can say it is very famous for the fact that it is very fast and the easy methods. And here I have taken some statements written by some researchers. Vedic mathematics, in the book Vedic Mathematics, there are 16 sutras and 13 subsutras which are used to solve the mathematical problems or to do the mathematical calculations. Similarly, these are actually these various mathematical calculation can be done on the basis of these sutras. Vedic mathematics offers fast calculation technique, and not only calculations, these are applied in the other field. If we go through the research which are based on the Vedic mathematics, these are very much useful in the research of the computer science as well, and in other field these can be extended, or their applications can be found in the other branches of mathematics or in the sciences. So I have just showing here the list or the table of the sutras and sub-sutras. I will not go through all the details. What does this word mean, and how these are derived. But I will show you. I will demonstrate you. It's these applications, the solving the solution of the problems or calculation on the basis of these sutras. And I have chosen few, not all the sutras. Actually, there are 16 sutras and 13 sub-sutras. I will take few sutras for demonstration. Okay. If anyone want to go in the detail, they can learn from the book Vedic Mathematics, where all the sutras, there is the detail of all the sutras and sub-sutras. So first I will take the I'm going to take the example of multiplication by Nikhilam Sutra. This is also very popular operation, or we can say popular application of the Vedic mathematics. Actually, in the primary classes, in the primary mathematics classroom, students are asked to remember the multiplication table up to 15 or 20 or more than that, which may by which students feel a kind of difficulty. So by the use of the Vedic mathematics, student just have to remember the multiplication table up to 5, and beyond that they do not require to remember, because they can just use the Vedic mathematics sutra, this sutra, to do the multiplication of the two numbers in a very fast way, in a very easy way. For example, if any student has to multiply 9 and 10, so actually for this kind of the multiplication by using the sutra Nikhilam, the base has to be considered. Base means the powers of the 10. Some numbers are near to the base 10, then in that case we will choose the base as 10. And in sometimes if the number is close to 100, in that case we will take base as 100, and like that. We all know about that. So what actually we do, we just subtract. Here both the 9 and 10s are near to the base 10. Then what we will do, we will just subtract the base. We will just subtract the base from these numbers. Like if we subtract 10, here base is 10, so we subtract 10 from 9, we will get -1. And similarly, we will subtract 10 from 8, we will get -2. And then what we actually do is, we just vertically multiply the numbers which we put in the right side. I mean, if we multiply -1 with -2, we will get 2. And we will do cross addition or cross subtraction, whatever you call it, in both ways. Either we can do 9 minus 2, that will be 7, or we can do 8 minus 1, that will also be 7, and we will get the answer, that is 72. So this is the I have given these steps how to perform this, like as I already told you before. So similarly, this kind of multiplication can be done by taking the other numbers. Yes, algebraically they are also defined. Sometimes this is not just the trick. This is not just the trick. Uh, it is explained. It can be explained. It's can be justified algebraically as well. For example, if we multiply x minus a with x minus b, we will get this algebraically. We all know that. Likewise, if we want to multiply 9 and 10, then here we are doing like this. In place of 9, we will write 10 minus 1. In place of 8, we will write 10 minus 2. And similarly, it means that here x means 10, and a means 1, and b means 2. Just if we put the values over there, we will get the value 72. So it implies that this kind of multiplication agrees with the algebraic multiplication as well. So similarly, I'm going to give some few more examples related to these. Like if we want to multiply 19 and 12, so also again these are close to the base 10. So what we'll do, we'll just subtract the base from these numbers. I mean, base is 10, so that's why we will subtract 10 from 19, we will get plus 9. Similarly, we will subtract 10 from 12, we will get plus 2. So what we will do, we will just multiply vertically 9 and 2, we will get 18, and add or subtract crosswise. I mean, 19 plus 2 or 12 plus 9, whatever we do, we will get 21. But here it is 18, so this one will goes here as a carry. This one will goes here in the left part as a carry, and it becomes 22, and here just remain 8. So the final answer is 2 to 8. So similarly, I have taken a little bit larger numbers, like 109 and 102. These are actually near to the base 100. Okay, as they are near to the base 100, we will subtract the base 100 from these numbers and put the subtracted value in the right hand side. Here we will get plus 9 if we subtract 100 from 109. Similarly, we will get plus 2 from here, and we will just do vertical multiplication, and we will get 18. And similarly, we will do cross addition, and when 109 is added to 2, it will we will get 111, and the final answer is like this. And similarly, sometimes one number can be greater than the base, and another number can be less than the base. In such case also this formula works. Like here in this case 109, and because 95 is also close to the base 100, so we take the base as 100 here also. We will just do the same procedure as earlier, and we will get 9 over here, and we will get minus 5 because 100 is subtracted from 95, and we will get minus 45. Now in this case we have to remember, because now what we actually have to do is that 104 and then suppose that as it is minus 45, so we have to think that should be like 400. I mean, there should be, if there are two zeros, okay, 10400 we have to think, and then we need to subtract 45 from that 400. What we will get? 355, and all the digits are same. 10, the first two digits are same, and in this place 400 we will consider here as a two zeros, by which it becomes 400, and we will subtract 45 from 400, we will get 355. So okay, this is the basic notion. Yes, other yeah, we can again explore on the other examples also, because I have, due to the time constraint, I have chosen few sample examples here only. Now I have just one activity for you. I just motivate you to participate in this activity and multiply these two numbers using this method, and write your answer in the chat box by using this method, not conventional method. 98 and 95. I can show here this method as well. '98 and 95. The process is over here. So this is also very simple. Okay. What we will do in this case also, they are close to the base. They are close to the base 100. We will subtract the 100 from these two bases, and in the same way, in the similar way, we will do the. Okay. Yes. Yes. Okay, so this can be, I think all of you can do this because it is very simple, which is related, which can be done in the on the basis of previous example. So I will go little ahead. So I have taken the corollary or the subsutra of this Nikhilam Sutra. These are the these are the Sanskrit words. So that's why this over here, these bars are over there because they are Sanskrit words. Yavadunam and Virgins Yoga Jet. These are the two subsutras. So this means whatever the extent of its deficiency, lessen it further to that very extent, and also set up its square of deficiency. It means its meaning. It is the meaning of this sutra, and I will explain this by the help of one example. Let us find the square of 9. To find the square of 9, according to this, what this corollary tells is that we first have to know that how much, what is the how much times, or we can say by how much number it is less than the base, or we need to find the deficiency of this number from the base. So this number 9 is close to the base 10. So what we will do here is the deficiency is 1 because 9 minus 1 is 10. So what we will do, we will just just subtract the deficiency from this number. I mean this 9, what we will do, the deficiency is 1, so that's why we will subtract this deficiency from 9, and also do the square of the deficiency. Deficiency is, here is 1, so we will do the square of 1, and we will get 1, and 9 minus 1 is 8, and 8 1. So this is also explained algebraically also. It is also aligned, or it is justifiable with according to the algebraical expression also. Likewise, like if we want to find, we all know about this formula, and in this case, if we want to find 9 square, and we can just put it as 9 minus 1, and if we solve this, we will get 81. So it means that it is in accordance with the algebraic expression as well. It is not just a trick. So I have taken some few more examples to make more clarity about this. Okay, let's say we need to find the square of 14. If we want to find the square of 14, so here what we do, first we need to decide. First we have to decide the base. The base is, obviously base is here 10. As the base is 10, it is not actually this 14 is more than the base, not deficient. So if the number is deficient than the base, we will subtract. But if the number is greater than the base, we will add that what we say, edit more numbers. I mean it is 4 more than the base. Okay, and we will add that more number, or more value to that number, 14 plus 4, and we will also make the square of the number, square of the this is more 4 it is more than 4, so that's why 4 square is 16, and 14 plus 4 is 18, and it will be 16, and by carry, the 1 will be the carry, it will go here, and it will be 19 and the 6. So here I have explained the formula, this expression as well. So let us see another example. Let us see of the little bit larger number, like if we want to find the square of the 92. So first we will decide it is near to the base. Obviously it is near to the base 100, and it is deficient by 8. Okay, it is deficient by 8. Then what we do, we just subtract that deficient number or deficient value from the given number. Given number is 92. We will subtract 8 from the 92, and also we will do the square of that deficient value. Deficient is 8, so 8 square is 64, and 92 minus 8 will be 84. So here the answer will be 8464. So this is the process. So I have also designed one activity for you to find the square of 94 by the Vedic method, by this method I may say. Just please try to find the square of 94 and write in the chat box. The process is over here. I will just wait for you. First we need to find the deficiency. It will be deficient by 6. It will deficient by 6. Then what we will do, we will subtract 6 from 94. We will subtract 6 from 94. We will get 88, and we will do the square of 6. That will be 36. It means that 8836 will be answer. So if we practice these kind of sutras, we can do some calculation can be done mentally as well, or we can do in a very few steps. Okay, but in conventional method, if we go to find the square, it may take some time. So I will go again a little bit ahead. Now this is ekadhikena purvena form sutra. So I will actually this formula will be used to find the. It has other many applications, but I have taken one application to find the square of the numbers whose last digit is 5. Okay, and this sutra actually implies by 1 more than the previous one. For example, if we want to find, so the condition is that the last digit should be 5. So what we will do here, to find the square of 35, we will just make the square of 5. The last digit is 5, so the square of the 5 is 25. We can automatically return that 25, and we will multiply 3 with just one more numbers. The one more, as the formula tells us, that by 1 more than the previous one. So if we add 1 to the 3, if we add 1 to the 3, we will get 4. And what we have to do, we will just multiply 3 and 4, and we will get 12, and the right part is 25. So just combine that. 1 to 25, 1225 will be answer. So yes, this can be explained algebraically as well. This is the algebraical explanation of this of this trick, or we can say this sutra. Like if we just do the square of x plus 5, we will get this. We all know about this. And likewise, in this case, to find the square of 35, what we do, we just put 30 plus 5, and if we expand in this formula, we will get 1225. So similarly, if we want to find the square of 95, very simple. We just make the square of last digit, and that is 25. And what we just have to know is that 9. The 1, if we add, what we need to do is that we need to add 1 to this 9, and this will be 10. And just we need to multiply that 9 and 10. It will be 90, and 90 25. So this can be also explained like this. So I have also one activity to find the square of 65. I think due to the time constraint, I will not wait for a very long time, but you can easily do this activity as well. Very simple. To find the square of 65, what we will do, we just write the square of 5 as 25 on the right hand side, and the 1 more than 6, 1 more than 6 is 7. Then we will multiply 6 and 7, 42. 42 to 5 will be the answer. So in this way, some calculations can be done mentally as well. So I am going to another sutra, Urdhva 3, as this is Sanskrit word, so it is difficult to pronounce it well. 3 of him. So it is basically, it means vertically and crosswise. It's a general meaning, or generally it implies vertically and crosswise. This is also very important formula. It is basically useful to multiply the numbers. Actually, in the Nikhilam Sutra, which I explained in the earlier part of this presentation, the numbers should be near to the base. There is constraint. Okay, either the number should be near to the base 10, or that should be near to the base 100, like that. But in this case, there is no constraint. We just need to we just can multiply the two numbers, any numbers. Like for example, I have taken just simple example of multiplication of the 12 and 13. What I am going to do is, it is, the word is simply implies vertically and crosswise. Vertically means we will do vertical multiplication of the first and the last digits. 1 is multiplied with 1, 2 is multiplied with 3. So that means the vertical multiplication. And in between them, I'm just multiplying them crosswise. 1 is multiplied with 3 and 1 is multiplied with 2. This 1 is multiplied with 3 and this 1 is multiplied with 2, and we will get like 1 into 1 1, 3 and 2, 3 2 5, and 2 3 is 6. Okay, so the final answer will be 156. But in some cases, in the case of the larger numbers, we need to take the carry as well. So this is the algebraical principle, or we can say algebraic explanation of this kind of multiplication. I have we all know that this multiplication, and in this case, to multiply 12 and 13, just I have written 12 as 1 into 10 plus 2, and 1 and 13 as 1 into 10 plus 3. And if I do according to this formula, and I will get the 156. So it means that this formula is also coherent according to the algebraical principle as well. So likewise, I am presenting here another examples. Now you can just you can just see here. We will just to multiply 67 and 88. I just take the numbers randomly. So I just multiply these numbers vertically, first numbers and last numbers, and cross multiplication of the first and last, and first and last. So here 48 and here 56. In between them, if we add this, it will be 104. So actually we need to care, care in that. So we need to take actually carry from 56. 5 will be carry, it will go to here, it will become 109. And again from 109, we just put 9 over here, and 10 will be go in the ahead as a carry, and it will be 58, and the final answer will be 5896. Okay, actually by the after the practice, we will be quite familiar with this kind of the multiplication or this kind of the calculations as well. So likewise, I am not go in detail. In this example also, same process was done. I have actually designed an activity, but I will skip that. We can multiply in the similar fashion. Okay. So this is not only in the case of the numbers, we can use this vertically and crosswise multiplication in the case of algebraical multiplication. Because in the lower classes or in the primary classes, sometimes student may look for some different methods. Okay, they desires different method to solve the problem. So in this case also, although the method is like the same, but here what we are doing vertically, I mean here we are multiplying a plus 3b and 5a plus 7b. We will do the vertical multiplication of the first and last numbers, and it will be 5a square and it will be 21b square, and just do the cross multiplication. A is multiplied with the 7b and 5a is multiplied with the 3b, by which we will get the answer like this. So in the case of the larger numbers also, we can do in the same way, but we have to first we need to do the vertical multiplication. Vertical means 3 this x square, 3x square and 4x square is vertically multiplied. 5x and 7x is vertically multiplied. 7 and 6 is vertically multiplied, and then cross multiplication. This 3x square multiplied with 7x, this 4x square multiplied with 5x. Again, this 3x square multiplied with 6, this 4x square multiplied with 7, and again this 5x is multiplied with 6 and 7x with 7. And by just arranging this number, we will get the answer. So I have another formula of factorization by using this Anu-Purven formula. It is basically useful for to find the factors of the quadratic equations, perfect quadratic equations. So to do this this operation, we actually use the two subsutras. This Anurupena and this one. And I will explain this with the help of example. Okay, so okay, these are the details over here, but I will explain with the help of example. Okay, so if we want to find like the factors of 2x square plus 5x minus 3, first, actually in general conventional method also, we actually what we do, we just find the two numbers. By adding these two numbers, we will get 5, and by multiplying them, we will get the first this one, and that is our conventional method. But in this case, in this method, what actually we do, we just split the middle number, here is 5, into the two parts. Such that, but in splitting those two number, but we need to keep in the mind that the ratio of the such that the coefficient of x square to the first term of x, I mean coefficient of x square is 2, and the first term of I will show it from here. For example, I splitted 5x into the two terms, 6x minus x. 6x minus x, then what will be the ratio will be 2x. The coefficient of x square is 2 and coefficient of x is 6. So the ratio of the 2 and 6 is 1:3, and again the ratio of this one and this minus 3, this is the coefficient of this second term is -1, and this one is -3. And in this case also the ratio is what? 1:3. -1 divided by -3, the ratio will be 1:3. So the first factor will be, we will automatically write that first factor will be x plus 3. This one is x and this one is 3. And now what we will do, we will just divide the first coefficient, this coefficient of x square, by the coefficient of this first term. Here the factor is x, so its coefficient is 1. We will just multiply, we will just divide 2 by 1, we will get 2, and we will divide the last term by this one term, the constant term of the first factor. -3 is divided by 3, and we will get -1. So 2 is to -1. It means that 2 is to -1. So we just write 2x minus 1. So I have another example like this. It is quite simple, I think. The 12x, I have just splitted these as two numbers. Here you can say the ratio of 4 and 2 is the ratio of 4 and 2, and the ratio of 10 and 5 will be 2:1, and the factor will be 2x plus a1. In the same way, now what we do, we will just divide this 4, the coefficient of x square, by the first term of the factor. First term, the coefficient of first term of this factor, first factor, 4 is divided by 2, we will get 2, and this constant term of the polynomial is divided by the last term of the factor. We will get 5 divided by 1, we will get 5. So 2:5 means the factor will be 2x plus 5. So I will not go to the activity because of time constraint. So you can just go through this in a simple manner. So this I have taken another sutra. This one sutra, which is basically useful for the division of the polynomials. For example, we have the polynomial like this one. this 2x square plus 5x plus 2, this is to be divided by the x plus 2. Then what we will do, first we will divide 2x square by the x. When we divide 2x square by x, this one x, we will get 2x. Okay, so now we just write quotient as 2 plus, but just the dot, other terms can come. And now we will multiply this 2x with this constant term of the this 2, by which we will get 4x. But here in this case we will have 5x. We will have 5x. So it means that it means that 1x to here, by our multiplication we will get 4x, but in the polynomial we have given 5x. So one more x should be there. Thus we need one more x, and just this x in place of this x, we just, when this x is divided by 1 x, we will get 1. So the quotient will be 2x plus 1. And let us again multiply this this 1 by the 2. We will get exactly 2, which is given in the polynomial. So that's why no remainder is there. The quotient will be this one. So I have another example in which there is quotient as well. Like this is the cubic equation, and when it is divided by x minus 2, first what we do, x cube is divided by x, we will get x square. Now x square is multiplied with this minus 2. This minus 2, we will get minus 2x square, but here in the polynomial we have 7x square. So for this we need as this is minus 2x square, so we need 9x square, by which if this 2x square is subtracted from 9x square, we will get 7x square. So we will get 9x square, but square term is already over there. So that's why we just divide this 9x square by x, and we will get 9x. And again, now what we do, we just multiply this 9x with minus 2. We will get minus 18. But here in the polynomial, we have 6x. So for this, how the 6x will come? So 6x will come if we put 24x. When the 24, from the 24x, if 18x is subtracted, we will get 6x. So that's why 24. But if we go through the degree, is the second degree and first degree, then it should be 24, not 24x, just 24. And now let us see whether 5 will come or not. If the 5 will exactly come by the multiplication, we do not need to go ahead for the remainder. But here now this 24 is multiplied with minus 2, we will get minus 48. But here in this equation we have the 5. So how it will come? So we have to put 53, because if the this minus 48 is subtracted from the 53, we will get 5. So that's why the remainder should be r. Remainder should be 53. So quotient will be this, and remainder should be this. So this is the general schemes. So other you can explore other more and more examples related to this. Now, so my battery is running. Actually, electricity is not over here. I'm going fast here. These are the implications of the Vedic mathematics. Vedic mathematics are helpful for quicker mathematical calculations. They are works as alternative mathematical calculations. These Vedic mathematics will help to overcome the mathematical anxiety, because most of the students feel mathematics difficult subjects, so they can be motivated to do the mathematics. So these can be equally helpful in the competitive exam, because in the competitive exam, student has to perform the mathematical calculation in a faster way. These are also helpful for the active engagement, participation of the students, and the Vedic mathematics will help to teach the mathematics in the funny way. So thank you very much. Thank you very much, sir.
Okay. Well, thank you so much, Premraj Joshi sir, for this wonderful presentation. So because I am also in the field of mathematics and mathematical education, so most of the contents are new to me, because they are not actually I haven't explored those things basically in mathematics. So I request our participants to.
Yes, sir.
So I request our participants to ask questions. If you have any questions, queries, or if you want to add something to the, the present, the presentation of Premraj Joshi sir. So the floor is open. So, okay, so you can post your question in the chat box. Asika Kadel. So, okay. Asika ma'am, so would you like to ask question? So actually I'm writing some questions here. Okay. Asika ma'am, so are you asking questions? So you raise your hand. Okay. I think so. Our participants, actually don't have questions regarding the presentation of Premraj Joshi sir. So it was really a wonderful and the very informative presentation. So regarding the Vedic mathematics and the tradition that we have been following, basically in South Asian countries. So these are the actually. So what I explore is that. So these are the products of Hindu scriptures, that is Veda, and other Hindu scriptures and other documents. So I think so Vedic mathematics is very, very useful when we use that as a tool to teach mathematics in our school level, and basically in the elementary and primary level. So thank you so much, Premraj Joshi sir, for your wonderful presentation. So I have to go to the next presentation. So we'll have presentation on yoga for mathematics classroom by Anita Joshi ma'am. Anita ma'am, are you ready with the presentation?
Yes, sir.
Would you to share your slide?
Sure.
So during her presentation, so I request our participants to actively, engage in the presentation, as well as you can ask your questions and post your questions in the chat box.
So, namaste everyone. A very warm welcome to the mathematics focused webinar series organized by Kathmandu University. And also I would like to thank the Department of STEM Education for providing me this opportunity to present in this platform. So let me begin with my introduction. My name is Anita Tiwari Joshi. I'm the scholar of Kathmandu University, currently doing my MAd in Mathematics Education. And today I will be presenting on the topic of yoga in mathematics classroom. I believe that yoga and mathematics is not a new topic for us. So we all are connected with these two words. So here I will be discussing around what is yoga and how yoga plays important role in our education and how it is connected to mathematics and the ways to integrate yoga in teaching mathematics in our classroom. So first of all, what do we mean by yoga? So I'm not going in detail here. Is I'm a yoga instructor too and mathematics teacher too. So I will be just giving a brief introduction of yoga. So let's begin from its origin. So how the yoga has been derived. So the word yoga is derived from the Sanskrit word use, which signifies that use is to join or to combine or to unite. So just from the word, we can understand that yoga is not isolated. We can combine yoga with many other disciplines or the part of our life, anywhere, wherever we want to put yoga. It is quite flexible, like the posture we have in yoga. So another thing that yoga cultivates health and well-being. of all people. Even it's for when we talk on the education, it is very good practice for our students as well as for the teacher, as it helps on our physical, emotional, mental, and social through the regular practice. So I really hope that we all practice yoga in our daily life, as I have been practicing it, and it gives a lot of benefits to us. Like it's help us to strengthen our physical health. Yoga enhances our focus and concentration when you talk about its benefits, and also it helps to build up our confidence level. So when we talk about students, sure, students need focus in their classroom. When they are attending the classes, they have to have focus in certain topics. Otherwise, if their mind roam around, they cannot get what we want to give them. And also for teachers, we have very stressful job. Being teacher is a big responsibility, as we are the future maker for our students. So it really helps in our mental health and our physical health if we practice yoga or meditation in our life. So moving forward, I will be discussing a little sloka, Sanskrit sloka. I'm trying to connect this sloka with the mathematics. So the sloka is like this: Om Purnamadaha Purnamidam Purnat Purnamudachyate Purnasya Purnamadaya Purnameva Vasishyate. So here, Purna means, as we all know, it's a whole. So when we say Purna is whole, and as we see in this sloka, the Purna is in each and every word. We can say that it means like when we have whole things, if we even when we connect to the mathematics, if we add, so here Purna, I take it as a Om. So Om is a state of infinity. We say Anant in Hindi or Nepali. So when we add this Purna with this Purna, or infinity plus infinity, we get infinity. And if we subtract infinity from infinity, again we get infinity. So this is a very small example how our mathematics is connected to our culture. Is yoga is not connected with any specific spiritual. I don't say that yoga is for Hinduism or anything, but we can connect our mathematics to any other thing as well. So this is just an example. So the another one is how yoga is connected to education. So I have two philosophy here. The philosophy that yoga follows is it unifies the heart, body, and mind. Similarly, as a 21st century educator, we follow the approach of 3H when we say the education should be integrating our head, heart, and hands-on learning. So when we practice yoga, we get to know ourselves. We connect our heart to body and body to mind, which gives us a better concentration. And when we do the 3S approach in our education, it is a pedagogy that follows the three learning domains of the Bloom's taxonomy, and also it focuses on the practice where learning by doing happens. The collaborative teaching method are integrating in classroom. Also, 3H approach is very nice approach for the research and innovation in our education systems. So this clearly shows that how yoga is related to education, and they both are connected in a way if we want to connect that in our education system. And here I'm going to give some activities that we can integrate in our classroom, in mathematics classroom, with the help of yoga. So the very first is the shapes. Shape is for we can do shapes activities for the lower level on mathematics classroom, maybe for the kindergarten or for the grade 1 to 5, if we find it appropriate, and we can see the level of students, how they are learning. And this is like these are some poses, and we can have more if we want to explore, like when we do certain types of poses. For this one, downward facing dog pose. So when we say it's a triangle, we can see that the form of body is making a triangle over here, but many students cannot see it, so they have to use their visualization skills to see where is that triangle is happening. Or if we don't give them clue, they will look and they will think, okay, what is the shape is here. So they will use more their imagination, their visualization skill, and they will be more active in the classroom. And also it will be a fun to teach them shapes from our body postures. So we can do in a group of activities. We can create one group and make them do the postures, asanas. In another group, we can ask another group to observe and draw there in their notebook, so that they can present in after the activities. So this is a very simple example of shapes in yoga. And another one is angle. So when we say angle, it is hard to understand students in first how this angle makes. They get quite confused about the angle. So in yoga we have many angles created with our body. So if we do certain poses, so we can see, we can see many angles are there. Even if we just strengthen our hand, we can see there's a 180 degrees being, and also there is 90-degree right angle can be performed anywhere. So this is another example for angle, and we can see these examples is as well. Like we have acute angle, right angle, obtuse angle. So to perform these activities, the students should know this previous knowledge. They should know like what is acute angle, what is right angle, and what is obtuse angle, or whatever angle we're trying to teach them. And when they know the knowledge about this, so that we can perform these activities. So after performing these activities, their skill will be strengthened. They could be remember how the angle has been formed, and they can also relate these yoga angles or the body parts with the other part in our real world. So it was the example of angle. And another is the mathematical calculation, which is again for the lower level mathematics classroom. We can give simple instruction to our kids. We can create a group, or we can do it individually in our classroom. So we can ask them to go in a pose, certain pose, or then hold it for certain seconds, let's say for 5 seconds, 10 seconds, and 15 seconds. Or we can ask them to remember for how long they have been in that posture, and at the end they can do the subtraction, addition, multiplication, and division from their own activity. And another one here is the statistics. We can teach with the help of yoga in our classroom, right? Like I have just come up with the mountain pose. We can do for the other one as well. So we can create a pair of children, and they can measure their height of the friends. So we can make a group again here. So when they measure the height of their friends, they can say like which student is in what height, or like this. And at the end of the activity, they can find out the mean, median, mode, and danger of their friends. And at the end, as a whole, we can find out the similar data from all the heights of the students. And the another one is the activity that related to breathing exercise. Is we teach our students to breathe, inhale and exhale. So it helps them to focus again and concentrate on their work. So while doing this, again, we can ask the students for inhale for this time or exhale for this time, and then they can record their data. And at the end, they can say, okay, for this much time we have done this one, or again, they can do the calculation with the number of their breathing. So this is a very simple example again. And these all I have been come up with the activities. And furthermore, yoga can be used for the transformative education. When we teach our kids yoga, even for the mathematical purpose or whatever purpose, they are doing it and they are learning something good, which again good for our social change. So here learner is as a change agent. And Also, we can connect our classroom activities, we can connect our mathematical concept to the outside world, and this achievement is a lifelong physical activity for the students, and not at the last it focuses on the soft skill of the students. So this is all I have. Thank you so much. Thank you, sir. Sir, are you there?
Yeah. Okay. Thank you so much, Anita ma'am, for a wonderful presentation. So as the topic is very interesting and wonderful, and the useful for every one of us, because yoga and the physical activity is really very important for actually balancing our functions of mind, body, and so that is also important for the spiritual development. And actually, so it was considered to be one of the separate disciplines where physical education handled the this yoga and other physical activity related part in our education system. But from your presentation, what I got to know about yoga is that so mathematics teacher, similarly science teacher, and the other teachers who are teaching in school level and other level can teach or can integrate yoga in their teaching and learning practices, as well as day-to-day teaching and learning activities. So for me, it was really an insightful session, Anita ma'am. Thank you so much for this. So I request participants, our valid participants, to ask questions if you want to discuss anything with Anita ma'am. So because I don't find any questions here. Okay, so I think our participant. Okay, Deepak sir, please.
नमस्कार म्याम अनि सरहरुलाई सबैलाई मलाई चाहिँ खास त्यो पुरानो प्रेजेन्टेसनमा एउटा क्वेशन थियो तर I was not in a situation to talk त्यो भएर सोधिन अनि यो म्यामको प्रेजेन्टेसन चाहिँ साह्रै राम्रो लाग्यो त्यो योगालाई यसमा रिलेट गर्ने भन्ने कुरा मलाई त्यो तपाईको श्लोकाको स्लाइड देखाउन मिल्छ एकपटक त्यो संस्कृतको जुन त्यो पूर्ण वाला भन्ने चाहिँ
Sure, sir. Is it visible, sir?
Yes, I can see it. I just wanted to correct this. I think the bottom one is not mathematically valid statement. Like infinity minus infinity is not infinity. It's plus is infinity, but minus is what we call the indeterminate form. So yeah, you definitely don't want to have the other mathematical mistakes in your presentation. And I know that. I just wanted to point that out because as a mathematician, I couldn't resist not telling that, because this is the forum which is open and very friendly, and we can come critical of other presentation. Just suggestion ko lagi matrai bhandeko ho, it's not a big deal, so that's not what it is, right?
Thank you, sir.
एउटा कुरा त्यो अनि जस्तो यो ट्रान्सफर्मेटिभ एजुकेसन को लागि भनेर हामीले जुन अब जस्तो योगालाई क्लासरुममा प्र्याक्टिस गराउने भन्ने खालको कन्सेप्ट लिएर आएको छ त्यो म एज अ प्र्याक्टिसिङ टिचर भएको कारणले मैले पछिल्लो 15 वर्षमा मेरो दुईजना कलिग थिए जसले चाहिँ योगा गराउँथे क्लासमै अनि इट वाज भेरी सक्सेसफुल क्लासरुम तर एउटा प्रब्लम चाहिँ के भयो भने अहिले पछिल्लो समय जुन त्यो इक्विटी इन एजुकेसन भन्ने आइराखेको छ अनि त्यसमा के हुन्छ भने अब त्यो इक्विटी प्रिन्सिपलले त तपाईको सबै विद्यार्थीलाई समान रूपले ट्रिट गर्नुपर्छ भन्ने खालको एउटा आइडिया मतलब कसैलाई पनि त्यो क्लासमा गरेका कुराले चाहिँ हर्ट हुनु हुँदैन भन्ने कन्सेप्टबाट चाहिँ जस्तै योगा आफैमा ग्रेट थिङ हो तर एट द सेम टाइम के हुन्छ भने हामी मोस्ट अफ द टाइम वी रिलेट द्याट टु हिन्दू कल्चर क्या अनि त्यो हिन्दू कल्चरसँग रिलेट गर्ने कारणले गर्दाखेरि चाहिँ समटाइम्स अब वी हेभ मुस्लिम स्टुडेन्ट क्रिस्चियन स्टुडेन्ट अब अरू खालको विद्यार्थीहरू पनि हुने हुँदाखेरि चाहिँ कहिलेकाहीँ यो खालको इम्प्लिमेन्टेसनले चाहिँ ट्रबल ल्याउन पनि सक्छ है भन्ने चाहिँ मैले आफैले देखेँ मेरै वर्क प्लेसमा चाहिँ एकजना साथीको इन्डियन साथीले त्यो गर्नुभएको थियो अनि पछि त्यो योगाको इनहेल एक्सहेल सबै प्र्याक्टिस भयो तर अब एट सम पोइन्ट दे निड टु डु द्याट ओम हैन अब ओम त गर्दाखेरि त अब मोस्टली लाइक इट्स जस्ट अ साउन्ड तर पनि मोस्टली रिलेटेड टु अब हिन्दू म्याथमेटिक्स भएको भएर मतलब हिन्दू कल्चरसँग रिलेट भएको भएर चाहिँ त्यसले चाहिँ समस्या निम्त्याउन पनि सक्छ भन्ने जस्तो यो विकसित देशको किन हामीले लगभग त्यही कुरालाई नै अलिअलि कपी गर्न खोजे जस्तो अब सबै कुरा अब इन्टरनेसनलले जे आइरहेको छ प्र्याक्टिसमा त्यही कुरालाई ल्याउन खोजेको कारणले गर्दाखेरि त्यो कुरामा पनि माइन्डफुल हुनुपर्छ होला जस्तो लाग्छ हैन जस्ट अ कमेन्ट मात्रै त्यसमा
Thank you for your input, sir. First one, thank you for the suggestion. But for the second one, sir, is yoga is not related to any spiritual, but many people have different perception. We cannot change it.
Yeah, I agree with you. त्यो खास मेरो कमेन्ट चाहिँ त्यो पनि हैन जस्तो योगा भने हिन्दू नै हो भनेर भन्न खोजेको चाहिँ होइन तर we somehow made it to sound like a Hindu thing जस्तो गर्छौं नि त हामी त्यसलाई चाहिँ त्यसबाट टाढा राख्न सक्नुपर्छ किन हामीले अब सेकुलर कन्ट्री भनेर भनिसकेका छौं नि त अब चाहिँ
So yes sir, yes you are right. So it depends on how we are presenting it.
Exactly.
How we are teaching our kids. So it's not about spiritual, and even if we talk only about the Om, the scientists have also proven that it has many benefit in our health and mind. So again, it's a perception and how we are presenting it. But thank you for your suggestion, sir.
You're welcome.
Okay. Thank you so much, Deepak sir, for your input and valuable suggestion. So here we have with us the acting head of Department of STEM Education, Subsutra Prasad.
Sir, can I just answer the question of Kim Busal, sir? If you have raised the question.
So, okay, sure, please.
Yes. So, Kim sir, thank you for the questions. It's a very practical question. We just say like we practice yoga or meditation. So while we feel like this kind of difficulties, yoga can help on keeping us calm. But the question is solved just to be calm, we can take some deep breaths and go out and stretch out and then do again that problem. So maybe that can help. But there is problem nani certainly help solve garcha भन्ने चाहिँ हैन तर यसले चाहिँ हाम्रो माइन्डलाई चाहिँ कसरी काम गर्छ र कसरी हामी again focus हुन सक्छौं भन्नेमा चाहिँ help गर्न सक्छ. Just with the deep breathing it helps. Thank you.
Definitely. So thank you so much, Anita ma'am, for the clarification. So as I said earlier, so we have our acting head, Department of STEM Education, Vinod Prasad Panta sir. So he is, talking about for about 1 or 2 minutes regarding the presentation today and the the webinar series we are having these days.
Okay, thank you, Neta sir. Thank you for inviting me. Sir, I want to thank to both presenters, Prem sir and then Anita ma'am, for bringing very useful ideas. So I'm just here to share a very few things. So the first one is this is a open sharing platform. So any one of you are welcome to share any ideas regarding math educations, regarding science educations, regarding STEM educations or STEM education. And sometimes we feel very difficulties to find out the speaker. So sometimes we have to request to some particular persons, please make a presentations, and then we find very challenging to identify the persons because you all are busy in your work, on your studies. So that I just take this opportunity to share these ideas that, so this is an open forum. Anyone from inside Kathmandu University or outside Kathmandu University, so you are welcome to present your ideas. So if you are interested to present some very useful ideas in this forum, please talk to Netraji, so you will coordinate. So the next one is we always have to talk about this alternative ways of knowing, because we all are research students. So in the research there are different knowledge production ways or knowledge production systems. So this also can be another alternative ways of knowledge productions. So we have to welcome, because in each classes at some point we are producing some knowledge. So that is what the constructivist says. We all are knowledge producers. So that I think in maths or science or technology, in such kind of subjects, we have to think from other sides. So how can we use other ways of knowing or other ways of knowledge productions? So thank you so much. And then the other one is we always use the same link for every Friday. Please share to your network, share to your institutions, share with your friends, our colleagues, so that they will be also benefited, or they can also contribute in this forum. So only this much. Over to you, Netra sir. So please, we also welcome you in the next week with some other interesting webinar series.
So thank you so much, sir. So I'd like to actually thank all the participants who present here, who are present here. So actually, due to this election and all, so we are actually forced to postpone our regular webinar series for the for the actually the next Friday. So we are not going to have another webinar series in this or next Friday. So I think we are at the end of this today's webinar series or session. So thank you so much once again, everyone, for your valuable time and patience. Have a good day ahead. Bye-bye.
Thank you, sir.